Hey guys, those of you that weren't here on December 18th, these are the notes from what we did today. Or if you just want to double check, make sure you got your answers right, you can watch this video. Okay, these proofs are a little different because it doesn't give us any information in the given, but it gives us a lot of information in the picture. So the way that we put that in our proof is called given in diagram. Your statement is going to be whatever they give you in the diagram. So in this case, I notice AC and DC both have one tick mark, so they're congruent. Also BC and EC. I also noticed that these triangles make something like a bow tie shape, so that is a big hint that I've got vertical angles. Now, I have two options. I could either use 3 letters to name them, or I could just stick some numbers on my picture and then say angle 1 is congruent to angle 2, because vertical angles are congruent. And now I've got a side, and an angle, but that angle is in between my two sides, so that shortcut would be called SAS. And I always end with my triangle congruence statement. Go ahead, pause the video, see if you can get question number 2, and then I'll meet up with you on number 3. Alright, number 3 is almost the same idea, but you'll notice that we've got these triangles are kind of overlapping each other. It's a little bit hard to see. So I'm just going to redraw them so they're separated. So the first one is LMN, that's LMN, this one right here. So I'm going to put it over on this side, LMN, and then I'm just going to transfer the tick mark and the right angle mark as well. Okay. I'm going to do the same thing for the other triangle, which is TNM right there. And then also transfer the tick mark over and the right angle symbol. So now I can see, when I look at these two separate triangles, MN, MN, which in the original diagram is overlapping itself. So MN is congruent to NM. We call that reflexive. So I could add some little tick marks on my picture there too. Okay? So I'm going to begin my proof like I did number 1 by listing the information that was given to me in the diagram. And like I said, you don't really want to use M to name this angle since there's more than one angle that connects to M, so I'm going to use 3 letters. TNM. Good. We then said that MN kind of overlaps itself, so we would say MN is congruent to NM by reflexive property. Then I'm going to collect my inventory. I have a side, angle, and side, and that angle is in between the two sides. So again, I have SAS. And when you do this, make sure that you go back to the original statement you were asked to prove, so that when you copy down the triangle statement, you don't reverse the letters by accident. Okay? See if you can try question number 4. It's really similar, and then I'll meet up with you on number 5. Alright, number 5 is a little different than the ones we just did because we have this symbol, which means parallel. Anytime you see that, you should instantly think corresponding, alternate interior, alternate exterior, etc. Those angle relationships will be helpful in these proofs, okay? So list down your given, mark up your picture, and then I would always extend these parallel lines so you can get a better picture. Then pick one line, we call that a transversal, that cuts through them both. And when you do that, you should be able to see this Z shape that we're familiar with. So that tells me that L and F are congruent. The reason is because these lines are parallel, so if lines parallel, then what types of angles are these? Well, they're both on the interior, and they're alternating sides of the transversal, so alternate interior angles are congruent. Well, if I picked this transversal, some of you may have picked this first. You would also see H and K are congruent, right? Well, they're still alternate interior angles, they're just a different set of them. So I could list both of these together in step number 2 because they have the same reason. And then we go to step 3. Well, if I stop and collect my inventory right now, I have an angle, angle, side, and the side's not in between the angles, so that would just be AAS. And we're done. Try number 6, it's really similar to number 5, and then we'll jump to number 7. Okay, so there's a lot of given information here, so take a second, jot down your given information, and when you're ready, resume the video. Okay, so now we want to start putting our information onto our picture. So Vx is congruent to xy, put 1 tick mark. Xw is congruent to yz, 2 tick marks. And then I know that they're also parallel to each other, so I'm going to put a little arrow, and I'm going to go ahead and extend those lines so I can get a better idea. Alright, right now I've got 2 sides. That means my options are either going to be SSS or SAS. So I need to start thinking, which one can I get to? Well, it's impossible to figure out any information about this third side, so that one's out. Now let's see if I can figure out some information about the angle that's included between the 2 sides that was given. So that would be these angles. How could I show that those are the same? Well, probably going to have to use these parallel lines because they were given to us for a reason. Okay? Well, what if I pick this as my transversal? Then I could see that these angles here, those are in the same position, which means they're corresponding. So if these lines are parallel, then we would know these corresponding angles are congruent. So I'm going to name them with a number 1, 2. I'm going to say angle 1 is congruent to angle 2 because these lines are parallel. So if lines parallel, then we said these are corresponding angles here. Then corresponding angles are congruent. Now I've got a side. The angle in between them now I have. So this would be SAS. And my triangles then have to be congruent. Alright, now let's try number 8. We did one like this, I think, in the last video. It had the same symbol. Remember, that means perpendicular. And whenever you have perpendicular lines, they form right angles. And whenever you have right angles, they are going to be congruent. So remember, we have to use this idea somewhere in our proof. Okay? So go ahead and list your given. Then we're going to mark up our picture. So I've got congruent segments here. And I've got perpendicular lines AB, AD. So those are going to make a right angle. Same thing here. Now I cannot write given in diagram because that wasn't given to me in the diagram. I just put that on there. Alright? So I'm going to have to think of another way to show that angle A is congruent to angle D. And the reason that you're right is because of this idea that we had in our little brainstorm session. So you could use symbols, that way you have less to write. Perpendicular lines form right angles, which are congruent. Remember, you could use those little arrows as a shortcut. And then right away I could see some vertical angles there. So give them a number, 1 and 2. And then collect your inventory, just check, make sure you got everything. Angle, angle, side, and the side's not between those 2 angles, so that's how I know it's AAS. Okay? See if you can try number 9. It's kind of similar but a little bit different, and we'll finish going over this in class. Alright, hope this helps you guys out. If not, you can come set up a time to see me for some extra help.